Welcome to Simultaneous Equations Level 2. Pause the video now, try the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 2p plus 4q equals 26 and 3p minus q equals 4. Now to solve this, we'd like to eliminate one of the variables, which means we need to get rid of either the p's or the q's. And to do this, we need the same number in front of either both p's or both q's, and we don't have that at the moment. So we need to make this the case. Now looking at the q's, we could multiply the second equation by 4, and this would make the number in front of both q's 4. So let's do that. So we need to make sure that we times everything in this equation by 4. So we have 3p times 4 gives us 12p. Minus q times 4 is minus 4q, and 4 times 4 is 16. And the equation above just remains the same. Now something else we notice is that the 4q in the first equation is positive and the second is negative. And this means that to eliminate them, we need to add the two equations together. And this is because 4q plus minus 4q is 0. So adding everything in both equations together, starting with the p's, we have 2p plus 12p is 14p. The 4q plus minus 4q becomes 0, and on the right, 26 plus 16 is 42. To solve this equation now and find the value of p, we need to remove the times 14, and we can do this by using its inverse, which is divide by 14, and we do the same on the right. And on the left, we're just left with p, and on the right, 42 divided by 14 is 3. So p equals 3 is the first part of our solution. We now need to take this value and substitute it into one of the two original equations to find the value of q. I'm going to choose the first equation because it has a plus in it, so it's going to be a little bit easier to work with, but you could also use the second equation if you wanted to. Now substituting p equals 3 into this equation, we have 2 times 3 plus 4q is equal to 26, and since 2 times 3 is 6, we have 6 plus 4q is equal to 26. And we can now solve this equation to find the value of q. So first, we'd like to remove the 6 from the left-hand side, and this is a positive 6. So to remove it, we're going to subtract 6 from the left and do the same on the right. And on the left, the plus 6 and the minus 6 cancel out to leave us just with 4q, and on the right, 26 minus 6 is 20. Finally, to remove the times 4 from in front of the q, we can divide by 4 and do the same on the right. On the left, the times 4 and the divide by 4 cancel out to leave us with q, and on the right, 20 divided by 4 is 5, so q is equal to 5. And this means that our final answer to problem 1 is p equals 3, q equals 5. In problem 2, we're solving 2f minus 5g equals 9 and 4f plus 3g equals 5. Now to solve this, we need to eliminate one of the variables. And to do this, we need to have the same number of f's or the same number of g's in each equation, and at the moment we don't. But looking at the f's, if we multiply the first equation by 2, this is going to give us a 4f, which will then match the equation below. So we need to multiply everything in this equation by 2. So 2f times 2 is 4f, minus 5g times 2 is minus 10g, and 9 times 2 is 18. And the equation below can just stay the same, so 4f plus 3g is equal to 5. Now here we're eliminating the f's because we have the same number in front of both, and both of these 4f's are positive. So to eliminate them, we need to subtract them because 4f minus 4f is 0. So we need to subtract everything in the bottom equation from the top equation. So starting with the f's, 4f minus 4f is 0. Moving on to the g's, minus 10g minus 3g gives us minus 13g, and on the right, 18 minus 5 gives us 13. To define g, we now need to remove the times minus 13 from in front of it, and the inverse of timesing by minus 13 is to divide by minus 13. And we do exactly the same on the right. On the left, the times minus 13 and the divide by minus 13 cancel out to leave us with g, and on the right, 13 divided by minus 13 gives us minus 1. So g equals minus 1 is the first part of our solution. And again, we now need to take this value and substitute it into one of the original equations to find the value of f. And looking at the two original equations, the second one looks a bit easier to use because it has a plus in it. So I'm going to use 4f plus 3g is equal to 5. I'm going to now substitute g for minus 1. So we have 4f plus 3 multiplied by minus 1 is equal to 5. And since 3 times minus 1 is minus 3, this becomes 4f minus 3 is equal to 5. And we can now solve this to find the value of f. So looking at the left, we'd like to remove the minus 3. So we need to add 3 to the left and also add 3 to the right. On the left, the minus 3 and the plus 3 cancel out to leave us with 4f. And on the right, 5 plus 3 is 8. To now remove the times 4 from in front of the f, we use its inverse, which is divide by 4, and do the same on the right. And on the left, the times 4 and the divide by 4 cancel out to leave us with f. And on the right, 8 divided by 4 gives us 2. So f is equal to 2. And this means that our final answer for problem 2 is f equals 2, g equals minus 1. In problem 2, we're solving 8x plus 2y equals 20 and 2x minus y equals 8. Again, to solve these equations, we need to eliminate either the x's or the y's, and to do this we need the same number of x's or y's in each of the equations. So at the moment we don't have that, and we've actually got a couple of options here. We could, looking at the x's, multiply the equation at the bottom by 4, because 2x times 4 is 8x, and then we'd have an 8x in both equations. Alternatively, we could multiply the bottom equation by 2, because this would then give us a minus 2y in the bottom equation, matching the 2y we have in the top. So we do have a choice here. I'm going to stick with multiplying the bottom one by 2. So if we times the whole equation by 2, we have 4x minus 2y is equal to 8 times 2, which is 16. And the equation on the top just stays the same. So 8x plus 2y equals 20. Now we're eliminating the y's here, and they have different signs. So to eliminate these, we need to add them together, because 2y added to minus 2y makes 0, and we want them to disappear. So adding everything in both equations, starting with the x's, we've got 8x plus 4x is 12x. The plus 2y added to minus 2y makes 0, and on the right, 20 plus 16 is 36. To find the value of x, we now need to remove the times 12 from in front of the x, and we do this by dividing by 12 and doing the same on the right. On the left, the times 12 and the divide by 12 cancel out to leave us with x, and on the right, 36 divided by 12 is 3. So x equals 3 is the first part of our solution. To find y, we now need to take this value of x and substitute it back into one of the original equations. And as always, I'm going to pick the one that looks a bit simpler, which is the one with the plus in. So I'm going to take 8x plus 2y equals 20, and I'm going to substitute x for 3. So this becomes 8 times 3 plus 2y is equal to 20. 8 times 3 is 24, so this becomes 24 plus 2y is equal to 20, and we can now solve to find y. And look at the left, we'd like to remove the 24, and this 24 is a positive 24. So to remove it, we can subtract 24 from the left and also subtract 24 from the right. And on the left, the plus 24 and the minus 24 cancel out to leave us with 2y, and on the right, 20 minus 24 is minus 4. Now to remove the times 2 from in front of the y, we can use its inverse, which is divide by 2, and do the same on the right. And on the left, the times 2 and the divide by 2 cancel out to leave us with y, and on the right, minus 4 divided by 2 is minus 2. So y is equal to minus 2. And this means that our final answer to problem 3 is x equals 3, y equals minus 2.